Hi all, Alex B here with another question on electric currents and resistance from Chapter 25 of Giancoli's Physics for Scientists and Engineers. So the problem tells us that we have a chunk of carbon, which I've already drawn here, which measures 1 centimeter by 2 centimeters by 4 centimeters. And the question asks us to calculate the resistance for current passing along various directions through this chunk. So the only additional piece of information that we need is given to us in the question, and it tells us that the resistivity of this carbon is going to be assumed to be 3.0 times 10 to the minus 5 ohms times meters. We're going to plug this into our equation for resistance in terms of resistivity and physical dimensions, where resistance is equal to resistivity times the length divided by the area. But to know what the length is and what the area is, we need to know which direction we're going through. So the first part of the problem asks us to calculate this going through the x direction. In this case, resistivity is the same as in every direction, 3.0 times 10 to the minus 5. But the length here is the x-dimensional length, which in this case is 1.0 times 10 to the minus 2 meters. Here I'm going to use meters everywhere, that way we get the right answer at the end in the right units. In this case now, the area is going to be the y dimension times the z dimension. So 2.0 times 10 to the minus 2 times 4 times 10 to the minus 2. And if we plug all of this in, we should find 3.8 times 10 to the minus 4. Let me rewrite that really quick. This is going to be equal, to 3.8 times 10 to the minus 4 ohms. Doing this for the y dimension, we should find we're using the same resistivity, but now we're using the y length, which is 2.0 times 10 to the minus 2. And now down here, we're going to have x times z. So 1.0 times 10 to the minus 2 times 4.0 times 10 to the minus 2. And this now is going to give us 1.5 times 10 to the minus 3. Finally, looking at the z dimension, we're going to get 3 times 10 to the minus 5 times 4 times 10 to the minus 2 divided by 1 times 10 to the minus 2 times 2 times 10 to the minus 2, and we should find we have 6 times 10 to the minus 3 ohms. Thanks for listening.